Alright guys, here we have section 7.2, which is multiplying a monomial by a polynomial. So in the last couple of videos we talked about what constitutes a monomial. And if you recall, that is a monomial is just a number, a variable, or the product of a number and a variable. Okay, so there's no addition or subtraction happening in a monomial. It's just one term. So we're looking at multiplying a monomial across a polynomial that has more than one term. Okay, and to do that, it says here, to multiply a monomial by a polynomial, you need to distribute the monomial into the polynomial. Okay, so we all know what it means to distribute something. Okay, and if you are multiplying a variable times the same variable, but you have differing exponents, remember the product rule, and have written it over here for you to review. If you have x to the a times x to the b, so we have the same base, just different exponents, and we're multiplying them, then what we're going to do is we're just going to add the exponents there. Okay, so let's look at example number 1. We have x times x plus 4. So we're just going to distribute this monomial out front across the polynomial. So we'll do x times x. So we all know that that's x squared, but you can also look at it as x to the first times x to the first. We'll add those two exponents. 1 plus 1 gives us 2. And then x times 4, we'll write that as 4x. Okay, so not too crazy there. This one is a little bit more complicated. So we're going to multiply this monomial 5m cubed out front, and we're going to multiply it by each term that is in the parentheses in the polynomial in the second polynomial in the parentheses. Okay, so let's look at the parts of multiplying these. So we have a 5 and we have an m cubed. So when we multiply 5m cubed by 3m squared, we're going to multiply the coefficient times the coefficient first. So 3 times 5 is 15. And then we'll multiply the variable times the variable. And since it's the same variable, all we need to do is add the exponents. So we'll add 3 plus 2, then we get m to the 5th. Okay, it's getting a little crowded over here. So then we'll look at 5m times this middle term. So we have a coefficient of 5 and a coefficient of negative 1 here. So 5 times negative 1 is negative 5. So we're going to say minus 5. And then when we look at the variables, we have m cubed and m. That will give us m to the 4th, right? Because there's a 1 here. We just add the 3 and the 1, and that gives us m to the 4th. And then the last one, we just have a number here, 5 times negative 7, and that gives us negative 35. And there's no variables, so we'll just keep the variable that's here. I'm sorry, there's no variables on this last term, so we'll keep the m from the monomial out front. Okay, and that's what we get. We're just going to double check to make sure we can't combine any like terms, but since we have a m to the 5th, m to the 4th, and m cubed, we won't be able to combine those at all. It's already in standard form because the biggest exponent is first. And so that's our final answer. We can move on. Okay, so here is 14 practice problems on those. I'm only going to go through a few of these for the notes video. And then I'll have the extras out if you would like to watch the videos in case you're getting stuck. Okay, so let's look at number 1. We have k times k minus 9. So we'll distribute this k to both of these terms. We get k squared minus 9k. And that's it. On number 2, we have 9a times a plus 1. So 9a times a is going to be 9a squared, and then 9a times 1 is going to be positive 9a. Looking at number 3, negative 6p times p to the 4th minus 8. So we'll take negative 6p and multiply it by this first one. The negative 6 will stay the same, and then p times p to the 4th will be p to the 5th. And then negative 6p times negative 8. So negative 6 times a negative 1 is going to give us a positive 6. Oops, sorry, there's a, it's not negative 1, it's negative 8. It'll give us positive 48. and then we'll keep the p there because there's no p to multiply it by, so we'll just keep the same p. All right, let's look at number 4. So 3c to the 5th times this first term, so 3 times a negative 2 is a negative 6, and then c to the 5th times c is c to the 6th. All right, and then we'll look at the monomial times this second term here. So a 3 times a negative 5 is negative 15. And there's no c term in this last part of the polynomial, so we'll just keep the c5 from the first one. All right, so we have negative 4g squared times 2g. So negative 4 times 2 is negative 8. G squared times g is g cubed. And then negative 4g squared times 7. So negative 4 times 7 is negative 28. And then we just keep the g squared. Here we are starting to multiply by polynomials, which doesn't change anything. This x will still be multiplied by the first term, the middle term, and the last term here. So we're just adding one more step here. So x times x squared is going to give us x cubed minus, from this minus here, x squared plus 3x. Okay, so just distributing that x among those terms. Number 7. Negative 3n times n cubed gives us, n squared gives us negative 3n cubed. Then negative 3n minus 2 times negative 2n gives us positive 6n squared. Negative 3n times 8 gives us negative 24n. Negative 2x to the 4th times this first term. Negative 2 times 6 is negative 12. X to the 4th times x squared is x to the 6th. And then we have negative 2 times negative 12, which is positive 24, x to the 5th. And then negative 2 times 18 is negative 36, x to the 4th. Number 9. All right, so it's getting a little bit more complicated here just because we have a term with 2 different variables. But all we're going to do is we're going to look at, when we look at multiplying these first 2 terms together, we're just going to look at the p times the p and the q times the q. And we'll just keep them together like that. Okay, so we have p squared times p to the 5th. We'll just add those exponents, p to the 7th. And then q cubed times q squared. Add those exponents, we get q to the 5th. And that was it. And then we're going to be subtracting, so then we're going to multiply this by the second term. Subtracting p squared times p is p cubed, and q cubed times q is q to the 5th. Okay, if you recall, this is still in standard form because p comes before q in the alphabet. So we listed the highest exponent on p first, and then the second highest exponent on p. So number 10, 3xy times x squared. So we have a 3 times a 1, which is just 3, and x times an x squared, which is x cubed, and the y doesn't have a y to combine with, so we'll just leave it as y, okay? Plus 3x squared, y squared. Now we have a 3 and a 1, an x and an x, which is x squared, and then a y times a y, which is y squared. And then this last one here, 3x squared times y squared, it's going to be positive 3. There's no x's to combine, so we'll just leave the initial x, and then we have a y and a y squared. That gives us y cubed. Okay, just double checking that we're still in standard form here. X comes before y, so we have x cubed, x squared, and then x. That all looks good. We can leave that as our final answer. All right, and number 11. Let's see. So we'll multiply this first one, the monomial, by this first one. So 5 times negative 2 is negative 10. R squared times R squared is R to the 4th, and there's only just the one S squared term. All right, and then multiplying against this middle term here, 5 times 3 is positive 15. R squared times r is r cubed, and r s squared times s is s cubed. And then looking at the last one here, 5 times negative 4 is negative 20. R squared, there's only one r term, so we'll leave it as r squared. And then s squared times s squared is s to the 4th. Okay, so here you really just need to keep track of your variables and what they're being multiplied by. All right, 3ab times 4a squared. So 3 times 4 is 12. A times a squared is a cubed, and there's only one b term. And then the second one, 3 times negative 7 is negative 21. There's only one a term, and then b times b cubed is b to the 4th. 13. We have this first term times the monomial times this first term. Negative 7 times negative 9 is negative 63. Negative 7 times positive 9 is negative 63. C cubed times c squared is c to the 5th. We're just adding the exponents. D squared times d squared is d to the 4th, adding exponents. And then the monomial times the second term, negative 7 times negative 4 is positive 28. C cubed times c is c to the 4th, and then d squared times d to the 5th is d to the 7th. Last one in this practice set here, this monomial times this first term, 10m to the 4th n times negative 2mn cubed. So 10 times negative 2 is negative 20. M to the 4th times m is m to the 5th. N times n cubed is n to the 4th. And then we'll multiply by the second term. 10 times 3 is positive 30. M to the 4th, there's no other m, so we'll just keep m to the 4th. And then n times n is n squared. All right, so lots of practice there. More practice to come on the homework informative. Let's see. This next section, so we have some directions here. It says to distribute, then simplify the remaining expression. Final answers must be in standard form. Okay, so it looks like we're going to be distributing, and then we're going to be adding or subtracting. So we're going to tie in a little bit of 7.1 here. Okay, so first let's distribute. So just a reminder here, if we remember our order of operations, which is PEMDAS, or you might have seen it as GEMDAS. So the P and the G essentially stand for the same thing. This just means parentheses. This means grouping symbols. So this kind of encompasses a little bit more. But what I want to take a look at is we are always going to want to do our multiplication and division before we do our addition and subtraction, right? So if we take a look at something like this, we have this is being multiplied here, right? This 2x is being multiplied by this binomial, and then we have an addition here. So we're always going to want to distribute first because the multiplication will come before the addition and subtraction. Okay, so let's look at distributing this. This is what we just practiced. Negative 2x times 3x is negative 6x squared. And then negative 2x times negative 4 is positive 8x. And then we'll add our 7x here, combine like terms. So these guys we can add together. So we have negative 6x squared plus 15x as our final answer here. Looking at number 16, there is a multiplication here, and a subtraction here. So we're going to do the two multiplications before we do the subtraction. Okay, and because we have a subtraction here, what we're going to want to do is we're going to put this whole thing in parentheses, because then we're going to distribute this subtraction symbol among whatever our new polynomial is. Okay, so let's look at the first one. The first one we don't need to write in parentheses because we don't ever need to write the first polynomial in parentheses. So let's just distribute here. So 5w times negative 7w. 5 times negative 7 is negative 35. And then w times w is w squared. That was this one. And then 5w times 3 is positive 15w. Okay, and then we're going to just keep this minus here, minus, and then we'll put this second polynomial in parentheses because every single term in this one is being subtracted. So we'll do 2w times 13. So we can just look at this like this. We don't need to include this subtraction. So we have 2w times 13, which is 26w, and then this times the second one, 2 times negative 9 is negative 18, w times w squared is w cubed. Okay, and then let's remember to get rid of these parentheses, we'll just distribute this subtraction to both of these terms. So then we'll get negative 35w squared plus 15w minus 26w, and then we're going to subtract a negative 18w cubed, which from our last video and from before, we remember when you subtract a negative, you're actually adding. So we're just going to change this to plus here. And then let's combine like terms. It looks like we have a w and a w, and then we want to write in standard form. So here's our w cubed. That's going to go first. So 18w cubed minus 35w squared, and then 15 minus 26 is going to give us negative 11, so minus 11w. So a couple additional steps there, combining these two concepts. Okay, so there's some more practice and then geometric application. So let's look at number 17. Number 17, we're going to distribute here, and then we're going to do the subtraction and this subtraction. Okay. So let's look at the first one. Y times y plus 4, we get y squared plus 4y minus, in parentheses, we'll do this distribution. Y times y minus 3 is y squared minus 3y. Okay, and then we'll just add on this subtraction here at the end. Okay, so all we've done is just distribute those two terms, and then we want to rewrite without parentheses, so we have y squared plus 4y minus y squared. We're going to have a minus and a minus, which makes it a plus 3y minus 9y. Now let's look for like terms to combine and write in standard form. So we have 3 y's there and then 2 y squareds. So we have y squared minus a y squared, so that will be 0 y squared, which we won't write. And then we have 4y plus 3y, which is 7y, minus 9y, which is negative 2y. And that should be our final answer there. Looking at number 18, we're going to do this first two distributions, and then we'll combine with this subtraction here. So don't forget your parentheses on the second polynomial that we get. The first one, distributing 6x times 2x is 12x squared, minus 18x minus, in parentheses, 5 times 2x squared is 10x squared. 5 times 9x is positive 9 times 5 is 45x, and then 5 times negative 3, we're going to subtract 15 here. Let's rewrite without parentheses, so we're going to distribute this subtraction to every term here. So we have 12x squared minus 18x minus 10x squared minus 45x, and then we have the minus and negative on this last term, so it's going to be plus 15. Now combining like terms, we have an x squared term here, x squared term, and x, and then the 15. So our x squared, 12x minus 45x, I'm sorry, 12x squared minus 10x squared is 2x squared, and then negative 18 minus 45 is going to be negative 63x, and then we're going to add our 15 here. And there is our final answer for there. Number 19, okay, so we're going to distribute this first, and then we're going to add and then subtract. Oops. Okay, so distributing this 2y to both terms here, 2y times 6x is going to give us 12xy. Now I switched the order of the variables because I know that x comes before y, and that's how we like to write it in standard form. And then multiplying this 2y times the second term, 2 times negative 4 is negative 8. We have the x squared, and y times y is y squared. Okay. And then we're going to add this 13x squared y squared and subtract 6. Time to combine like terms. We have 12xy. There's nothing else with an xy, but we do have this x squared, y squared, y squared. So we can combine those two and then tack on the negative 6 there. So which one are we going to write in standard form first? Well, we want to focus on the x's first, and we want to focus on the x with the highest exponent. So this x squared, y squared terms will come first. So negative 8 plus 13 is 5, x squared, y squared. And then we're going to add 12xy and then subtract 6. And that is our final answer for that one. Looking at number 20, we're going to distribute here, and then we'll add them together. So we actually don't need to write parentheses on our second polynomial since we're adding. We can just write without. So negative 2 times 3m squared is negative 6m squared. Negative 2 times 6 is negative 12 plus 3m times 2m squared. We have 6m cubed plus 9m squared plus 3m. Let's look at our like terms here. We have m squared. We have an m cubed, and then just an m and a constant 12. So let's look at the m cubed first. 6m cubed. Our m squareds, we have negative 6m squared and positive 9, which gives us positive 3m squared, plus 3m minus 12. Oh, this is where I messed up. Okay, so I was just looking over here. So our first term here should actually be 6m cubed. So we do not have these like terms here. What we have is m cubed, and then we have this m squared, m, and 12. Okay, so then we have a positive 6m cubed and a negative 6m cubed, which equals 0, so we won't write that at all. Then we'll go to the m squared, 9m squared, plus 3m minus 12. That's our final answer. Okay, looking at number 21. So this is 3 different distributions, and then we have, so we'll distribute here, then we have an addition and a subtraction. So since we have the subtraction, we know we're going to write this one in parentheses, but the rest of them don't need parentheses. We'll just write them as we get the answers. I'm going to leave these parentheses up though. Okay, so looking at this first distribution, 3v times 7v minus 2. So the first term is going to give us 21v squared minus 6v. And then looking at the second distribution, plus 3v squared plus 6v plus 3. And then we have our minus, and then in parentheses we'll do this distribution. So negative 15v squared plus 9v. Okay, so then let's distribute this negative and then combine like terms. So what we can do is we'll just rewrite this first whole part, 21v squared minus 6v plus 3v squared plus 6v plus 3. Then we have a minus and negative 15v squared, so plus 15v squared, and then distributing that negative to the last term, minus 9v. Let's look at what we have. We have v squared, v squared, v squared. Good. Then we have v, and then a 3. So looking at the v squareds, we have 21v squared plus 3v squared, which is 24v squared, plus 15, which is 39. So 39v squared. All right, and then our v terms, we have negative 6 plus 6, which is 0, minus 9, which is negative 9v, and then our 3. Looking at number 22, we have this distribution first, and then we'll do a subtraction and an addition. Because of the subtraction, we're going to keep these guys in parentheses so that we remember to distribute the subtraction through all of them. So first one, 4x squared times 2x squared gives us 8x to the fourth plus 4x cubed minus 20x squared. And then the subtraction, we'll do this distribution, x to the fourth plus 5x cubed minus 3x, and then plus 17. I don't know why I just wrote 9, plus 17. Then we'll distribute this negative here. So 8x to the fourth, this all stays the same, 4x cubed minus 20x squared. We're going to do minus x to the fourth minus 5x cubed, and then minus a negative 3x, which is plus 3x plus 17. Combine like terms, so we have an x to the fourth and x to the fourth, x cubed, and then we have x squared. And then our last ones are 3x and 17. So let's start with the highest one, x to the fourth, 8x to the fourth minus x to the fourth, which is 7, x to the fourth. Our cubes, we have 4x cubed minus 5x cubed is negative x cubed. We only have one squared term, so minus 20x squared plus 3x plus 17. Good, and that is our final answer here. Looking at number 23, we'll have a distribution here, and then we have a subtraction here, which we need to distribute the subtraction in order to write without the parentheses. Okay, so first let's focus on this first distribution. We have negative 2r to the fourth plus 12r cubed minus 12, and then we'll just add this plus 4r cubed. And then we'll distribute this subtraction, so minus 5r to the fourth minus 10r. Let's combine like terms. We have this r to the fourth. I think that's the only one. R cubed. Oh, we have another r to the fourth here. And then no r squared, but we have that 10r and the 12. So we have negative 2r to the fourth minus 5r to the fourth, which is negative 7r to the fourth. 12r cubed plus 4r cubed is positive 16r cubed minus 10r minus 12. Oh, this 12, so this 2 times here is supposed to be 12r. So we actually have, so this would be negative 10r, negative 12r, and negative 10r, which is minus 22r. There's our final answer there. All right, number 24. So it looks like we have two sets of parentheses here. We have this 5 being multiplied here, and then the subtraction, and this monomial is going to be out front here, okay? So let's focus on what's the most inside. So let's do this distribution first, okay? So when we do that, we're just going to leave this 4b outside. We'll write these square brackets into a minus, and then here we're going to do this distribution. So 5 times 3ab is 15ab minus, and then 5 times, these are in parentheses, 5 times 2b squared is negative 10b squared. There. And then we'll just keep this 29ab squared out front. Let's distribute what's inside these square brackets. So we have 4b times 2a squared minus 15ab plus 10b squared. Oh, this is square. Plus 29ab squared. So now we just have this distribution left, and then we can add these all together. So let's distribute this 4b among each of the terms in here. And so the first ones are going to be 8a squared b minus 4 times 15 is 60 minus 60a, and then we have b squared plus 4 times 10 is 40 b cubed. And that is everything, that distribution, so we can just add 29ab squared. And then we're going to combine like terms if we have any. So it looks like we have an a b squared here, and then the other terms cannot be combined. So we'll just rewrite them over here as, let's see, in standard form we want the a with the highest exponent, so this first one, 8a squared b. Then we want the AB squared. So we have negative 60 and positive 29, which looks like negative 31. Negative 31 AB squared. And then our last one plus 40 B cubed. And that is our final answer there. Good. Last section here is geometric applications. And I know you guys always think these are pretty tough, but really it's just the same concepts, but we're just applying it to shapes, okay? So find the area of the trapezoid as a simplified expression, okay? So first let's find the area, and then let's simplify it, okay? So area of a trapezoid is equal to 1/2 of the base 1 plus base 2. So this is a base and this is a base. It doesn't matter which is which. And then that is multiplied by the height. Okay, so we have, let's just say this is b sub 1, let's say this is b sub 2, and let's say this is h. Okay, so we can write our area as 1/2 b sub 1 is 8x squared plus 3x, okay, our first one, plus b sub 2, which since it's an addition, we don't need to write it in parentheses, so we'll say plus 2x cubed minus x, and then we're multiplying that by h, which is 4x squared. Okay, so it looks like we can combine some like terms in here first, and then we can just do the distribution, okay? So we'll keep this as a equals, I'm going to bring this 4x squared up to the front. So this polynomial in the parentheses is being multiplied by 4x squared. It's also being multiplied by 1/2. So I'm just going to write 1/2 in parentheses. Okay, it's still being multiplied by 4x squared. And then I'm going to write our simplified polynomial in here in standard form. So we have a positive 2x cubed plus 8x squared, and then we have a 3x minus x, which is plus 2x. Okay, so what I'm going to do first is I'm actually just going to multiply these first two terms together so that it's just one monomial. So a is equal to 1/2 times 4 is the same thing as dividing 4 by 2. So we have 2x squared in front now times 2x cubed plus 8x squared plus 2x. And then we're going to distribute this out here. So we have a is equal to 4x to the 5th plus 16x to the 4th plus 4x cubed. That is already in standard form. So this will be our final answer. And looking at the last one here, find the area of the shaded region as a simplified expression, which is really, really cool. So we want to look for the area of this. So we want to find the area of this big rectangle, right? And then we're going to subtract the area of the smaller rectangle to find everything that's outside. So first, area of the big triangle. Area is just length times width. We'll say that this is our length and this is our width. So looking at this, the big one, area is equal to length times width, which is equal to 8x. Oh, let's see. Let's do the monomial first, so it looks the same as what we've been doing. So we'll do width times length, which is 6x times 8x minus 1. Okay, so we're going to distribute this. 6x times 8x is 48x squared minus 6x. Okay, and then the area of the inner one, we're going to say that this is the width and this is the length. So we'll do just width times length. It doesn't matter, right? We can switch around the order of what's being multiplied. The width is 2x and the length is 5x plus 3. Distributing that 2x, we get 10x squared plus 6x. Now we want to do this area, the first one, minus the area of the second one. So we'll find the area of the shaded region is equal to 48x squared minus 6x minus, since it's a minus, we'll put this one in parentheses, 10x squared plus 6x. Okay, let's distribute that negative. 48x squared minus 6x minus 10x squared minus 6x. Combining like terms, we have the 48x squared minus 10x squared, so we have 38x squared. And then the negative 6x minus 6x is 12, negative 12x. So we should have the area of our shaded region be equal to 38x squared minus 12x. And that is our section 7.2.